As they say, can you hear me at the back? As they say, keep the best for the last. So I have no PowerPoint, I have no script, but I will speak straight from the heart and explain to you how the semiconductors are the new oil and what exactly is the critical technology and how they will shape your safety razors to space shuttles in the next 13 minutes. Himanshu Chopra, AVM Golani, CAPS, thank you very much for getting me here. I'm very humbled to speak in front of General Khandare, General Bhatt. General Khandare used to be DGDIA when I used to be in PP Directorate. General Bhatt was in CAB. General Bakshi, we've shared some good places together. And of course, we have some friends from the NDA who were my seniors in NDA who tormented me, but they're still here. Anyway, be that as it may, a lot of things have been said about a lot of technologies which are now taking shape and taking root and what have you. So I will not bore you with technical jargon. I will not bore you with nanometers. I will not bore you with a lot of technical details. However, I will go down very, very deep into the subject in the next 13 minutes because I've been shaped by three very wonderful institutions in this country: Defense Services Staff College, the Higher Command course at the Army War College, and the Elite Indian School of Business. So I will stick to exactly 13 minutes. All right. Sir, you alluded, Air Chief Marshal Ramaswamy, you alluded already to the Chinese manufacturing, the rare earths, and so many other things. I will get them amalgamated into my discourse in the next 13 minutes as I speak, sir. Firstly, let me tell you a little about the historical perspective of semiconductors in India. A lot of people say, a lot of people write, a lot of people debate with me, a lot of people converse with me and tell me, oh, we've missed the bus. Oh, you haven't missed the bus. You haven't. The first semiconductors which came into being, whether it were PCBs or transistors, came as early as the 1960s. The Fairchild Corporation from the United States came back early in the 1960s. There was 1962 war thereafter. Thereafter, due to the price competitiveness, it's all about demand and supply, it's all about pricing. It was seen that the price that the other countries were offering on the same technologies was much lower. Obviously, then it didn't take off. Later in the day, sometime in the early 70s, post the 74 nuclear blasts in Pokhran, the peaceful nuclear explosion blasts, a lot of impetus was given to the semiconductor domain. No matter what it was, 1983 heralded the establishment of the Semiconductor Laboratory in Mohali, which still exists today. 1989, there was a fire which gutted the entire semiconductor laboratory in whatever way it was, and all of us know of all of that. The point to note here, ladies and gentlemen, is that TSMC, the behemoth of world semiconductors, came into being in 1987, much later than the SCL. Thereafter, the semiconductor laboratories got into the Department of Space and looked at strategic electronics and what have you, and today it's still up and running and it does a comparatively good job than whatever the other people may think of, so to say. Be that as it may, the trajectory of this stalled in 1991 when the economy opened. When the economy opened and you were getting a chip in China or any other country in the world for 2 rupees, why would you create something for 200 rupees here? It had no economic logic. Therefore, this went into a little deep dive. Be that as it may, again, the next resurgence of this happened post-COVID, when the supply chains were very, very typically enhanced, as Ambassador Kanta has also brought out earlier, and a lot of other things. And then it became more of a geopolitical tussle. As I always say in a lot of forums, technology is politics. Make no mistake, technology is politics. That's the way it is, and that's the way it goes. Now let's look at the world map. I will not even go into more things. Let's look at the world map. When we look at the semiconductor supply chains and we are looking at the entire semiconductor ecosystem, actually ecosystem is a very biological word. I don't know how it has come into the entire, genealogy of speaking. But when you look at the entire, semiconductor scenario, you look at a troika. You look at a troika of 3 things. The first is the equipment, which makes them. The second is the materials, which looks at the minerals, which A.G. Marshal Ramaswamy alluded to, some gases and chemicals. And third is the services, which looks at testing, packaging, and so on and so forth. You would have all heard about Micron setting up an ATMP plant in Sanand in Gujarat just around 2 months or something ago. Now, when you look at this troika, you just look at the world map today and you look at the equipment part. 80% of the equipment is built in the United States with 52% of IPR. Some part of it in the Netherlands, the lithographic machines, which is essential monopoly. Then you come down to the chemicals and gases or the materials. You look at China, you look at some part of Europe, some Southeast Asia, some South America, some US. And then you look at packaging. Where you look at packaging is generally the Southeast Asia and China. And then you look at the actual core manufacturing, where the foundries are. Foundries is all Asia. Taiwan, Korea, Japan, Malaysia, Singapore. Now, when you look at all this on a world map and add the Ukraine conflict, where Russia gives you 40% of palladium in the world, and Ukraine used to give you 70% of neon in the world, and then you add on to it Israel and Gaza, oh, it's a recipe for disaster. It's as simple as that. It's geopolitics. So whosoever controls it, monopolizes it. And thereby, you would have seen in the last round 1.5 or 2 years that whenever you went and said, look, I want a credit card from a bank, the bank said it will take you 3 months or 2 months. It's a low-end chip. Or you went and wanted to, you go to a car dealer and say that, look, I want to book a great fancy car. He'll say waiting period is 1 year. Most of the critical electronics in an automobile today are all chip driven. Not to forget, even in the defense and aerospace segment, we've seen a large amount of videos in which you find a lot of javelins blowing up T-72s in Ukraine, sir. Each javelin has more than 200 chips, all manufactured in TSMC, Taiwan. No points for guessing what happens after that. All right. Having said that, this is the basic troika and the geopolitical construct I thought you guys must know as well as understand the historical perspective. So let's come down to the supply chain issues. Supply chains of all these things that I mentioned to you look at 7 things which I've just noted down or scribbled down here. First is the management. The second is the analysis. The third is the plan. The fourth is the project. The fifth is procurement. The sixth is logistics. And the seventh and the last is distribution. If all of you have read the new national logistics policy, I think it's a step in a great direction. It looks at all of that. Wonderfully done. Now let's come down to the Indian landscape. When you look at the policy perspective, you look at the path-breaking setting up of the Indian Semiconductor Mission and giving out the production-linked incentive, PLI, 50% pari passu, unheard of anywhere in the world, unheard of. With states giving you more SOPs, more to 25%. Now there's a dilemma here. A lot of people think that, oh, it's 50% and 25% by the state, so it's 75%, so what are you going to be doing it? Well, historically, these are critical technologies which have very, very large scope of failure. The percentages of profit on which the business runs is very low. So thereby, all over the world, these technologies have been incubated and have to be incubated by public money. There's no other option. Because that's where the money lies, that is one, with the levers remaining with the government. Along with that, you have the design-linked incentive, the DLI, the spec scheme, and now the chips to startup. I was in the national consultancy meeting of chips to start yesterday in Meti. I think they are all path-breaking initiatives. A lot of these policies are now undergoing a change. They're getting revised for making them more industry friendly. They're absolutely industry friendly, but they're getting more industry friendly. See, the problem is, all of you must understand, when you look at a logic, the industry has the expertise, but doesn't have the volumes of scale. The government has the volumes of scale but has low expertise. So you have to balance this equation to make that marriage happen. This is the challenge. So these policies which have come out now recently in the domain have stuck to this challenge, and I think they're doing a fabulous job. It's just a question of time as to how they pan out globally as well as pan-India. Some important statistics which I thought I must, it's very fancy to throw in some statistics, some numbers. So the equipment market by around 2030 is likely to be $200 billion, in which, as per my inputs, we should look at around $30 billion by manufacturing of components for these key equipment systems. This is a work in progress. When you look at the materials, it's going to be $150 billion, in which our pie should be by around 2030, the way we are going at around 15 billion, that's around 10%. I think that should be a conservative estimate. And then when looking at services, there's going to be a whopping $250 billion, in which we should have around $40 billion of this pie, because it's a low-hanging fruit, it requires less skilled manpower, and it's a work in progress as we speak today with the Micron coming in and a large amount of other packaging and the ATMP and OSAT plants coming into being as time goes by. Yes, there are a lot of challenges. The biggest challenge or the Achilles heel in the system is skilling. The skilling part is being addressed by the government very astutely. You must understand, when you look at skilling, it has to be looking at all four levels. One is the technical level for technicians. Unfortunately, we've lived in a hangover of software for a very long time, 4 decades. So you go back home and you have children and you ask she or he that what kind of engineering do you want to do? The answer is computer science. Why? Because it is a return on investment. There are Googles and Microsofts of the world here who pay well. Things have changed. Now it's hardware. Software is passé. That's one. Secondly, when you look at the skilling set, you're looking at the technical level, very low-end level, who will run facilities. Most of the ITIs, 12,000 of them in the country, do not have structured hardware courses. Then you look at undergrad, you'll be surprised. These are challenges, you have to speak about them. There are electrical and electronic engineering disciplines. The seats go empty. No, there are no takers. It's reality. That's changing. Then you look at postgrad. There are hardly any. The billets which are being filled are by the corporates. And then you look at doctoral, which is nothing. I mean, it's all abroad. So what happens is, at the end of the day, you don't have skilling. The first function of not having skilling is monopolization and weaponization of skilling at a later stage. We've all seen what's happened during COVID or to co-vaccine. You can weaponize it. So if I and it's the same case of a T-72, or a T-90 round, in some manner or the other, when there was a grave crisis, you paid 5 times the cost. So it is weaponization. So you have to look at skilling. In addition to the skilling, in which the government is putting a large amount of impetus, you require a large amount of faculty development. Now this is a challenge, very big challenge for me as a policy maker, or being part of these committees, or steering the semiconductor ecosystem in the country, or whatever you may call it. I think I personally find it that this is your Achilles heel, skilling. The second part is warehousing. Why Singapore is such a great place for business is because of its warehousing and distribution. So there needs to be a large amount of impetus on warehousing, world-class warehousing, which the national logistics policy looks at. But it's a work in progress. It will take a little while. The MSME sector, a lot of people say it's become a rhetoric that, you energize the MSME, this, that, and the other, give them SOPs, take stakes, use a large amount of hardware, into the system. But the problem at hand is, this MSME is going to be your backbone of the future. You like it or you don't like it. You may have very, very big conglomerates from India and abroad. I mean, we have Intels and Foxconns and Qualcomms with us. That's all right. They may have very deep pockets, great technology, great, gravitas. But by the end of the day, your backbone will still remain MSMEs. And today's startups will be tomorrow's MSMEs. That has to be understood very clearly by a lot of people, which I dare say this government understands it completely. Completely. So it's a work in progress. And the last but not the least, it is my personal view that these technologies have to converge. Whether it is a semiconductor for the automobile sector, which is a large market, second largest market in the world, whether it is for defense and aerospace, whether it is for telecom, whether it is for consumables, or whether it is for toys, for all I care, these energies have to converge. For this, we really require one single agency to monitor so that these agencies converge, because the moment any kind of a technology gets into geopolitics, it is not a domain of a single ministry, it is interministerial. And the faster we understand, the better it is. And with that, it's exactly 13 minutes. I rest my case. Thank you very much.